Hi, everyone. Welcome to a very, very special session at PrestoCon. I'm Dipti Borkar, and I'll be moderating this virtual roundtable, the Presto ecosystem. And we have a Who's Who cast lined up for you today. We'll be hearing from Nezih from Facebook, TSE chair of the Presto Foundation, Max, founder and CEO of Preset, Vinoth, vice president at Apache Hudi, and Kishore, PPMC member at Apache Pinot. Welcome, everyone. Great to have you, and thanks for joining.
Yeah, thanks for having me.
Thank you.
Now, these folks have been deep inside the matrix, the disaggregated stack matrix, as I call it, and I'm very excited to learn about their take on what's happening in this data analytics space, of course, and how everything fits with Presto. So, just a quick, a short opening statement, a few comments on the stack itself. I've been in the data space since 2005, back when I was in DB2 days, as Eric was talking about earlier, dating myself now. But in these early days, everything was about a tightly coupled data warehouse. Everything was a single engine, compute, storage, the catalog, transaction manager, pretty much all integrated together. But this post-Hadoop world has changed things quite a bit. It's the disaggregated stack started to emerge. The idea of ingesting all your data into a single database or data warehouse seems to have stopped working for especially the large internet companies. And a combination of more and more data, open formats, ORC, Parquet, etc., has changed things, right? Presto, obviously created at Facebook, sits in the middle of this disaggregated stack. And with us today, we have creators of these amazing projects. Apache Pinot is a real-time analytics database, came out of LinkedIn with collaboration from Uber and others. Apache Hudi is a data management framework used to bring ACID-like properties to data lakes that came out of Uber. And last but not the least, Apache Superset, the data exploration platform out of Airbnb. So Nezih, Vinoth, Kishore, Max, welcome again. Each of you have been a part of data teams at the world's most innovative companies. And the data platform at these companies have probably the most modern analytics stacks, if any. Share a little bit about yourselves and why you ended up creating these amazing projects. Maybe you can, Nezih, maybe you can get started.
Yeah, sure. A quick intro about myself. So, hey everyone, this is Nezih. I'm the chair of the Presto Foundation Technical Steering Committee. I am also an engineering manager in the Presto team at Facebook. So my background is distributed systems. I have a PhD in distributed systems. I enjoy a lot dealing with challenges around building large-scale systems, such as fault tolerance, scalability, etc. So I met Presto in 2014 when I joined Netflix, and I've been involved with the project since 2014. There's like for the past 6 years. And at the beginning of 2017, I joined Facebook to be closer to the team who is really pushing the core technology, and I've been with the same team since then. And as you know, like in September 2019, 1 year ago, we launched the Presto Foundation to grow our community and really make Presto stand the test of the time. And I'm extremely happy and excited to see where Presto is today. So I can briefly also talk about the data infra stack at Facebook. So it's a massive infrastructure. It's a unique and massive infrastructure. The scale is amazing. There is plenty of problems to solve as a result of the scale. And Presto was created back in 2012 to really address some of the interactive use case problems. And like from then on, it started evolving to other use cases like very low latency use cases, batch use cases, etc. And it's also like with these use cases, other problems evolve. Like with, for example, batch use cases, we need to solve problems around efficiency, scalability, fault tolerance, and reliability, etc., etc. So in particular about the stack itself, like in our primary Presto stack, we have a distributed file system called warm storage, and it's where the data is stored. And we have many Presto clusters basically talking to this distributed file system. And we have a high compliant MetaStore, a scalable MetaStore implementation with the high open source APIs. And we have plenty of data centers, and we have many clusters in each data center. And in front of all these clusters, we have a gateway that does query routing and simple load balancing across these clusters. And for supporting the batch workloads, like we have other systems on top. We have a batch job scheduler on top. You have other tools to monitor and make sure that these jobs succeed and land on time, etc., etc. And we also have in our infrastructure other data warehouse services like privacy, security, lineage, resource management, etc., etc. It's a massive and complex infrastructure, in short. You are muted, I guess.
Hello.
Max, you want to go next? Share a little bit about Superset. Why you, what problems you were trying to solve with it?
Sure. Yeah. So a little bit of an intro too, and then some context setting. So yeah, I started Apache Superset while I was at Airbnb. So that's a data visualization platform, very much of a challenger to like the business intelligence tools that people are familiar with. I also started Apache Airflow when I joined Airbnb. So that's more in the data batch orchestration space. I started also a company called Preset last year to really kind of build in and around the Apache Superset and kind of offer a really good kind of SaaS wrapper around it, and services and support around Apache Superset. I've been using Presto since before it officially existed. So I remember back in 2012 Facebook, we had something called Peregrine. That was, I believe, either the inspiration of an early version of Presto. And I remember the day that Presto was announced internally. So been very much following that from the very beginning. I wanted to mention too that I'm super supportive of everyone in Presto communities. With an S. So there's all sorts of there's I think different foundations now. So it's a little bit confusing for everyone. I don't personally follow the latest, or I haven't chosen a side. I don't think we need to, but I just want to say I have friends on both sides, and people are doing amazing work. So
thanks, Max. Absolutely. We want to unify it all into one, and it takes work. So we need some time, and looking forward to having that happen.
And one more point to your original question is why did we create these these new tools? I think you mentioned how there's this kind of differentiated, there's been all of this explosion of all sorts of tools. Originally at Airbnb, when I joined, we didn't have all the Facebook ecosystem internal tools, right? So there's a need to integrate with Presto. I remember Tableau. We used heavily kind of Apache Druid and Presto. We made some huge investments in Hive, Presto, Hadoop, and we didn't have great tooling. So we started building tooling, and I had some inspiration from the tools I'd used at Facebook. And that's how Superset and Airflow were born.
That's great. Thanks, Max. Kishore?
Awesome. Hey guys, I'm Kishore. So I started my journey with this distributed systems almost like a decade back. So this was early in 2010s when LinkedIn was pretty much hitting the 100 million member mark, and then we were seeing all these issues with this old monolithic distributed systems, or like oracles, right? So we wanted to get away from that. So my journey started with building this old OLTP system, which is like something like MongoDB, which we called as Espresso, which was the NoSQL distributed system where pretty much all of LinkedIn data was stored. And what started with that, I built this other cluster management system called Apache Helix as well, which was kind of a setting stone for building more and more distributed systems over LinkedIn. And in 2015 is when we started this journey of building Apache Pinot, which is like the real-time OLAP system. So analytics itself is a quite broad word, and there are a lot of different things that you can do with it. But LinkedIn had this amazing, unique challenge, I would say, compared to other analytics, because most of the time when people hear word analytics, they think about analytics to the internal employees, which is within the company. You have 2,000 users, so you need a lot of flexibility in that. But what LinkedIn took it as a challenge was to provide analytics to its 100 plus million members, right? So hundreds of millions. So today we have like close to 700 million members. So providing analytics to them at real time is like really, really challenging for us. And it kind of brings in like three different things together. One is like all the activities that are happening at LinkedIn, be it page views, be it clicks, be it whatever actions you're taking on LinkedIn, you're kind of ingesting that in real time. And at the same time, you have this hundreds of millions of users querying this and then looking at products like who viewed my profile or campaign analytics or publisher analytics. There are like 70 plus products that are surfaced to the end users, right? And not only this, the challenge with providing something like external analytics is very, very, very tight SLA. So we have very stringent requirements in terms of the latency. It has to be in milliseconds. We provide guarantees of 99th millisecond latencies and things like that. Right. So this is really hard for us. And when we started this journey, we had a very simple system, something like a search-based system like Elasticsearch that we started. And as this became very popular, we realized that we needed 1,000 machines to just serve a use case like who viewed my profile. That was like mind-boggling for us, and we were like questioning like, why are we even doing this? And that's where the management was really supportive, and they realized the potential of providing such tool to the customer, to the members of LinkedIn. And we ended up building this, and we took 18 months to rebuild this from scratch to serve this high throughput, low latency analytics use case. And we came from 1,000 to 75 nodes. So that was the big improvement for us. And it was not only in terms of cost, but it kind of set us the direction that, hey, this is an amazing opportunity for us to provide lots of real-time insights to the users. And kind of fast forward today, we have like 70 plus products surfaced to the users, and serving like 100,000 plus queries per second, right? And all of them milliseconds. So
that's incredibly impressive. Streaming for operational use cases, analytics for operational use cases, really. But that said, Vinoth, a lot of data is still going into data lakes, right? And there is increasingly a need for transactionality on top of that. And that's where Apache Hudi comes in. So tell a little bit about yourself and Apache Hudi as well.
Yeah. So I started out of college. I started my career at Oracle, actually working on database replication and some of these so I'm like a database guy. Then my job at LinkedIn was I was leading the Voldemort team back in the day. It was like a key value store on the likes of Cassandra. Then when I went to Uber, and I was one of the earliest members of the data team there. We started the data team. We are trying to move. Uber is going really fast. This is like 2014, right? It's growing. We're hiring a lot of people. A lot of new projects are being built. So our existing traditional data warehouse that we are using cannot fit any of all of the data anymore. So we were looking for essentially, okay, let's bring in a data lake, right? I honestly, then as we tried to do it, we realized that, we had this sort of unique need at Uber for both scale and speed, meaning Uber is a very real-time business. A lot of things happen real time, and a lot of people who operate the business who want access to the data in the data warehouse, so they can essentially they're using this as a debug log for the entire service, right? So we needed to give them this data very quickly, and then when we tried to build the data lake and kind of like a normal kind of a honest data lake architecture where we ingest first in the data lake, move the ETLs from the warehouse into the data lake, we stumbled onto so many problems. Which all boil down to essentially things being done in a very big batch way in the data lake, and lack of transactions actually was something that we solved in the process. But the core issue at Uber was we were trying to ingest the data. Traditional data warehouses have transactions, updates, deletes, and you can now incrementally ingest things into your data warehouse. But the data lake solutions had nothing like that, right? So we were kind of mulling for a while. Hey, do we try things like say Kudu, right? To bring to revamp this. And essentially, when we thought about it, it's not going to be cloud proof, right? It's going to be one other system that we wanted to run. So then we basically decided to say, hey, we're going to bring these properties in a layer that we write on top of the Hadoop file system interface, so that it can work on HDFS, it can work with S3, DCS, all of these object stores as well. And that's kind of how Hudi was born. The first version of Hudi at Uber was, I think, made our database ingestion 10 to 100x more efficient. And we also did something very unique at the time, and I think the world is still moving towards that. We're not fully there yet. So a lot of these batch ETL jobs, they just reprocess data over and over again, which essentially causes a lot of latency. So going back to what I was saying before, since we wanted a lot of this data to be available very quickly for our operations and rest of the business, we actually we introduced a lot of stream processing primitives in Hudi, which we took some of these like large batch ETLs for the data warehouse, and we were able to actually incrementalize them. And we've been like steadily investing along those lines since then. And I feel like with Hudi and projects like Hudi, we're slowly starting to kind of bridge the gap between the traditional data warehouse world and the data lakes, while we retain all the goodness about data lakes, which is lack of any standalone servers as like single point bottlenecks, retaining all the cheap, the cost and the scalability, right? So it's pretty exciting.
Yeah, absolutely. I mean, that's a great segue into the next question and discussion. Some will say that the stack, Superset, Presto, Hudi, Pinot, of course, let's throw in the object store, cloud object store data lake in there, is the perfect stack for real-time streaming, right? As well as ad hoc analytics, maybe ETL. And it can replace this traditional approach of a tightly integrated data warehouse. What do you guys think? What's your take on that? Maybe Max can get started.
Well, so there's an interesting kind of commonality across the solution you mentioned there, and across the panel here today is we see a bunch of open source projects at software foundations that essentially came from a world of from a corporate background too, right? So big company solutions. I think it's interesting to see this stack emerge. I think the open sourceness of it is interesting. There are things that are emerging too, winners that are emerging that are not open source, but I'm interested in talking a little bit about the open source ones. I think people care about data sovereignty, this idea that you want to own your stack. I think open source is just a fundamentally better way to write software and distribute software. And people recognize that and want that all across their stack. Now, one challenge is that the cost of ownership of open source is not necessarily free too, and it requires a data team, in some cases world-class data team, to operate some of these things, and that can be pretty challenging. It's not easy to hire that talent too. So I wanted to mention briefly commercial companies around these open source projects too that are making it easier for everyone to still get the benefits of open source, the no lock-in, the data sovereignty, the possibility of running it on their own or patching it or contributing to code, but also making it easier and more accessible for companies to use things like Pinot Superset, Presto, Airflow, right? So it's good to see the synergy of like open source with commercial when that works, and I think I think that can work very well, and we're making sure and many of us I think are doing it very well.
Great, yeah, well said. Yeah, go ahead.
Yeah, so add to that, right? I think it kind of goes back to the point that you initially mentioned, that earlier people had this one gigantic system that tried to do everything, and as we kind of tease apart and then break this into pieces, we kind of see that there is a ingestion layer, there is a storage, there is processing, there is compute, and then there is visualization. And each of these layers themselves are becoming so complex, and there are a lot of technological advancement as well, where you can make each layer the best, right? And it's very hard for one system to basically try to solve all of this, and then they end up becoming a big monolith, and it's very, very hard. So I do see that having these different layers and giving the users the flexibility to pick and choose the best layers, and being able to come up with their own stack is definitely something that we will see over the next 5 to 10 years, right? And one thing that might end up coming out of this is like very good standardized APIs for each of these layers, so that we can have like one or two different implementations. But this is the direction that in which we are going. We do see that it's almost like the analogy of the computer where you have this PCIs, where you have very good standards for each of them, and then everyone goes in like their own speed and be able to innovate and make it better and better. But you will be able to plug and mix and match all these things to come up with a world-class stack. But of course, as Max mentioned, it does require a world-class team to put together. It's not trivial. Each of these are like complex beasts on its own. But yeah, I think it's a very good point there in terms of how the future of data warehouse and bringing in the best of all these technologies together.
Yeah, absolutely. And I think cloud can solve some of these as well. If it's pre-integrated in the cloud, it as a service, it make it simpler. It simplifies it dramatically. It can be automated. You can have learning on top of it, so that it's self-healing, self-learning, self-managed, which will help as well. Vinoth or Nezih, anything more to add to that?
Yeah, so I want to touch upon specifically around the data lake and the cloud warehouse. And since there's a lot of work happening right now, right? It's actually exciting times as we are kind of exploring the lines between with the cloud warehouses, the lines between data lakes and cloud, cloud, what you call a warehouse and what you call a data lake. These lines are blurring a little bit because cloud warehouses kind of promise a lot more, scalability because they are built in a cloud native way with all of their data on S3 or some object store, right? While on the data lake side, you're getting a lot more features that if you look at, for example, Presto, you can find things like CBO or cost-based optimizations or vectorizations. These are advanced data warehouse engine kind of optimizations. You're making its way into the open source data. And then if you take Hudi, we have transactions, incremental streams, deletes, and these things that we used to find in kind of warehouses before, right? So I think this will be a very interesting transition. I do believe though that we will end up, this trend will continue, and we will again end up in a world, I think, on the cloud where there is a space for raw data is stored in a kind of data lake technologies where it's more cost efficient. You want all of your business's source of truth data to be not logged in a vendor's data format, but in open file formats, right? So you have the flexibility to, maybe your a vendor cannot provide you the operation guarantees that you need anymore. So you want to build it in yourself. You can totally do that, or you can, buy from some company who's offering these data technologies, right? So I think people will enjoy that freedom for majority of their data while they pick and choose the premium data with the 80-20 rule, what they want to move into a cloud warehouse. And I think this will definitely emerge. These patterns you can see in Silicon Valley, and generally the more tech forward companies, even outside Silicon Valley, kind of are adopting this model already. And I feel that's kind of where we'll emerge. Just like on-prem, we had traditional data warehouses and data lakes. I think on the cloud, again, I think we're going to end up with a more standardized, more advanced cloud data lake architecture and a cloud data warehouse architecture. Mm-hmm. And that's, I think, where we are going. And definitely exciting times. And I'm very thrilled that, Hudi and Presto are kind of playing large roles in this kind of evolution.
Yeah, open formats is incredibly important. Orc, Parquet seem to be the ones that are widely used today. Nezih, you brought up earlier Presto and Spark. Having this raw data, these open formats, essentially allows you to run many different engines, right? On top, it could be just Presto or Presto on Spark, or the next one. And so, Nezih, anything more to add to that? How is what does the stack look like 5 years from now? You think? It's a hard question to answer.
Yeah. 5 years from now, I mean, I think I can talk about more a personal wish list and a prediction, because I will get the prediction wrong anyway. So what I would love to see.
You're on the record now.
yeah, I know. So basically, I want to talk about two things. One is metadata. So the Hive legacy code, the Hive legacy metadata format and systems are out there for a long time. And we have use cases evolving, and now our requirements need much faster and scalable metadata formats and systems. And I think in the next 5 years, I would love to see an evolution of that as well. Like we want really faster and much scalable, leaner metadata implementations. And I think Apache Iceberg project, I think they deserve a credit there. They have done a great job and is a great step in the right direction. I would like to see more there. That is number one. And the second item in my personal wish list is like brought up before, these systems are non-trivial to operate and use. These systems are beasts and very complex. And operating them is challenging, especially at scale. These systems have like a large number of tunables or config knobs. Like you need to tweak query plans. You need to design the physical storage so that you get the best performance, etc., etc. There are so many things that you should tune and change to get the best out of these stacks. And I think like what I would love to see in the next 5 years is self-adaptive and self-tuning systems. And the idea of self-adaptive systems actually go back to 1970s, like 50 years ago. It's not something new. And given the latest advances in like machine learning and other learning techniques, gives me hope that like we can see some truly adaptive systems where a human operator involvement is limited. Maybe it can't be zero, but like at least it's limited, that it will be a big win and it will be much easier to use. And some of the commercial databases actually like have some limited support, like they have some automated SQL tuning, etc. But I'm really not talking about just SQL tuning. It's like I need something broader that is auto tuning, for example, the system config, the auto tuning the behavior and getting the best performance out of your workload and environment, etc. So basically, we need systems that adapt to their load and environment. I think such systems will really simplify the lives of people who operate these systems.
Awesome. Well, we have a few minutes left, and I think the audience probably wants to ask this question. Each of you have created these amazing technologies and open source projects, maybe used by thousands, maybe hundreds of thousands with everyone here together, hundreds of thousands of data analysts, engineers, data scientists. Is there a secret to building a killer open source project and a thriving community around it?
I can pick this one. I'll get started on it. So in more in the startup world, people talk about product market fit. I think there is such a thing as project community fit. I did not think about that up front, but sometimes it's just about kind of timing and kind of convergence of idea and offering the right tools or abstractions at the moment where the people are kind of ready for that. And there's such a thing as being ahead of your time or too late to market, in community and in open source too. My little secret, that I put into more application, because I didn't think about project community fit early on, is to really honor people that give kind of interest and show engagement toward your project. So really being on top of GitHub notifications and pull requests and issues and doing all the things that you should be doing in open source, great documentation, but like being really responsive to the community, even if it's just your community is just one person, give them the attention that they're honor their interest by engaging with them as much as you can.
Yeah, I would like to add to that, right? So I think one of the key things that I noticed is just help them, right? So a lot of people may be just coming to your project to either use the project, which is probably the first thing. But then I also realized that there are a lot of people who don't really get this opportunity, who are like from Facebook or LinkedIn's or Uber's or Airbnb to build this awesome complex system. So it's also a learning opportunity for them to get engaged with the project, right? So they're also contributing to it, but at the same time helping them to even work with some of these complex issues, and then teaching them all these concepts of distributed systems help them a lot. And then they potentially become a committer over a period of time. But it's really important to handhold them in the beginning and teach them the ropes, and then figure out like, okay, here is how a distributed system works. So there is a lot of investment that goes in, but then once they become committers, they're like amazing people who can basically push the projects to limits that we cannot really think of just being in one company. So I do see that coming and helping a lot in terms of growing the community.
Awesome. Vinoth, Hudi just recently became a top-level Apache project as well, so congrats. More to add to that?
Yeah, so I think in terms of the community, right? I think what we realized is there is no secret. It's about like consistently every day following up on the community, like making sure users who show up, you are treating them with like empathy. You're trying to really understand their problem and help them if you can, right? And we take like community very, very seriously. If you look at it, like on the PMC, there are people who are kind of like earmarked for, okay, you're the point person for answering dev mail list, you're the point person for Slack, you're like the person for reviewing PRs. So we make sure contributors or users, when they come to the community, they have a clear person who is responsible for that one interaction. And because a lot of times in like open source projects, it's a little bit frustrating that, who do you go to get your thing done, right? So we've taken special care in that, and that seems to have helped a lot. And we have like a lot of happy users on it.
That's great. Go ahead, Max.
I'm muting my mic here. One point that we all forget, I think that's really important, and that I put in the chat is from companies that are great with open source and sponsor open source. So if you join a company that doesn't have a pro open source or open source by default, or they don't understand, make a business case for it, or it doesn't happen naturally, it's going to be a lot harder. So joining companies that are pro open source is a great way to do this. I joined Airbnb in 2014 with the premise of working on open source. That was like the one of the key reasons why I wanted to do that. So really something, as you pick your next gig, maybe consider, look at whether that company is sponsoring open source.
Absolutely. And as companies, if you use open source, talk about it, say you're using it, share it, contribute back. Don't keep it for yourself. Contribute back. I could say that a few more times.